Anatomy of ChatGPT response. Understanding how AI generates intelligent text. Have you ever wondered what happens in the milliseconds between typing a question to ChatGPT and receiving a coherent, intelligent response? The process is far more sophisticated than it appears on the surface, involving multiple complex steps that transform your simple text input into meaningful contextual output. Let's dissect this fascinating journey through the 7 critical stages of large language model processing. Stage 1. Prompt ingestion, the gateway to understanding. The journey begins the moment you hit enter on your prompt. In our example, explain quantum entanglement serves as the initial spark that sets the entire AI engine in motion. But this isn't simply about reading text. It's about preparing that text for the complex computational processes that follow. The tokenization process. Your input undergoes immediate tokenization, where the AI breaks down your prompt into discrete units called tokens. These aren't always individual words. They can be parts of words, punctuation marks, or even spaces. For explain quantum entanglement, the system might create tokens like explain, quantum, entanglement, each representing a fundamental unit of meaning the AI can process. Contextual awareness. Even at this early stage, the system begins establishing context. It recognizes that this is a request for explanation, identifies the scientific topic, and prepares the contextual framework that will guide the entire response generation process. Stage 2. Token embedding, converting words to mathematical meaning. This stage represents one of the most crucial transformations in the entire process, converting human language into a mathematical representation that computers can understand and manipulate. Each token from the previous stage gets converted into a high-dimensional vector, essentially a list of numbers that captures the token's meaning, relationships, and context. Mathematical representation. The token quantum might be converted to a vector like 0.42 minus 1.03, and so on, where each number represents different aspects of the word's meaning, its relationships to other concepts, and its contextual usage patterns. These vectors are the result of extensive training on massive text datasets, where the AI learned to associate similar concepts with similar numerical patterns. Semantic relationships. The beauty of embeddings lies in their ability to capture semantic relationships. Words with similar meanings cluster together in this mathematical space, while words with different meanings are positioned farther apart. This allows the AI to understand that quantum relates closely to physics, particles, and mechanics, even without explicit programming of these relationships. Stage 3. Transformer stack processing, the heart of understanding. Here lies the core intelligence of ChatGPT, the transformer architecture that processes the embedded tokens through multiple layers of sophisticated analysis. This stage is where the AI develops its understanding of your prompt's meaning, context, and the type of response that would be most appropriate. Attention mechanisms. The transformer uses attention mechanisms to determine which parts of your prompt are most important and how different words relate to each other. In our example, the system recognizes that quantum and entanglement are closely related concepts that should be processed together, while explain indicates the desired response format. Contextual analysis. Through multiple layers of processing, the AI built increasingly sophisticated understanding. Early layers might recognize basic grammatical structures and word relationships, while deeper layers understand complex concepts, implied meanings, and the appropriate level of explanation for the request. Pattern recognition. The transformer stack draws upon patterns learned from vast amounts of training data to understand not just what you're asking, but how similar questions have been answered effectively in the past. Stage 4. Logic calculation and token prediction, the decision point. This stage represents the AI's decision-making process for generating the next token in its response. The system calculates probabilities for every possible token in its vocabulary, determining which word or symbol should come next in the response. Probability distribution. The AI generates what's called a logic distribution, a probability score for every possible token it could generate next. In our example, after processing the quantum entanglement query, the system might determine that is has a 42% probability of being the best next token, while other options like refers, describes, or means have lower probabilities. Contextual influence. These probabilities aren't random. They're heavily influenced by the context established in previous stages. The AI considers not just what word typically follows others, but what word would best serve the specific request for explaining quantum entanglement to the implied audience. Strategic selection. The highest probability token isn't always chosen. The system often employs techniques like temperature scaling or top case sampling to introduce controlled randomness, ensuring responses are varied and natural rather than rigidly predictable. Stage 5. Token by token generation. Building the response. With the first token selected, the AI begins the iterative process of building its complete response. This stage exemplifies the sequential nature of language generation, where each new token influences the selection of subsequent tokens. Sequential building. The AI generates one token at a time, with each selection influencing the context for the next decision. After generating quantum entanglement is a physical phenomenon, the system updates its understanding of the developing response and uses this context to predict what should come next. Coherence maintenance. Throughout this process, the AI maintains coherence by considering not just the immediate context, but the overall structure and flow of the response. It tracks whether it's providing sufficient detail, maintaining the appropriate tone, and progressing logically through the explanation. Dynamic adaptation. As the response develops, the AI continuously adapts its generation strategy. If it realizes the explanation is becoming too technical, it might adjust to include more accessible language or analogies. Stage 6. Post-processing, ensuring quality and safety. Before reaching the user, the generated response undergoes crucial post-processing steps designed to ensure quality, safety, and appropriateness. This often overlooked stage plays a vital role in the responsible deployment of AI systems. Content filtering. The system screens the generated response for potentially harmful, inappropriate, or policy-violating content. This includes checking for misinformation, harmful instructions, inappropriate content, or responses that might violate platform guidelines. Quality assurance. Beyond safety, post-processing may include quality checks to ensure the response is coherent, relevant to the original prompt, and meets the expected standards for helpfulness and accuracy. Formatting and structure. The system might also apply final formatting, ensure proper paragraph structure, or make minor adjustments to improve readability and presentation. Stage 7. Response return to the user, the final delivery. The culmination of this complex journey is the delivery of a polished, contextually appropriate response to the user. In our example, the final response might read, "Quantum entanglement is a physical phenomenon where particles become linked." Seamless integration. Despite the complexity of the underlying process, the response appears instantaneous and natural to the user, hiding the sophisticated computational process behind a simple conversational interface. Continuous learning. While the AI doesn't learn from individual conversations in real time, the patterns and approaches used in this response contribute to the broader understanding of how to handle similar queries in the future. The remarkable symphony of AI intelligence. What makes this process truly remarkable is how these 7 stages work together seamlessly, transforming a simple text input into a sophisticated, contextually appropriate response in mere seconds. Each stage builds upon the previous ones, creating a cascade of increasingly refined understanding and generation. Emergent intelligence. The intelligence displayed by ChatGPT emerges from the interaction of these relatively simple computational steps. No single stage is particularly intelligent on its own, but their combination creates behavior that appears remarkably human-like in its understanding and responsiveness. Scalable architecture. This architecture scales remarkably well, handling everything from simple factual questions to complex creative tasks, technical explanations, and nuanced conversations. The same 7-stage process adapts to wildly different types of inputs and outputs. Continuous innovation. As AI technology advances, each of these stages continues to evolve. Improvements in embeddings, attention mechanisms, safety filtering, and generation strategies all contribute to increasingly capable and safe AI systems. Understanding the implications. This anatomy of ChatGPT's response generation reveals several important insights about AI capabilities and limitations. Probabilistic nature. AI responses are fundamentally probabilistic based on patterns learned from training data, rather than true understanding or consciousness. Context dependence. The quality and appropriateness of responses heavily depend on the context established in the early stages of processing. Safety by design. Modern AI systems incorporate safety considerations throughout the process, not just as an afterthought. Computational intensity. What appears as a simple conversation actually involves massive computational resources and sophisticated algorithms working in concert. Understanding this anatomy helps us better appreciate both the remarkable capabilities and inherent limitations of current AI systems, while also providing insight into how these technologies might continue to evolve and improve in the future.